All right, let's take a look at the practice test. For the instructions, we're asked to derive the given identities. And for problem 1, we're going to start with the sine of a plus b. In the previous lesson, we talked about how we could get something like the cosine of, let's say, a minus b. And we also know how to do the cosine of a plus b, but we're going to use this one here. So this is what? It's the cosine of a times the cosine of b. And then your sign is always different. So if this is a minus, this is a plus, and then it's the sine of a times the sine of b. Real easy formula to remember. Additionally, we need our cofunction identities. We talked about this earlier in the course, and we also updated this in the last lesson where we said that the sine of some angle a is equal to the cosine of 90 degrees minus that angle a, and then also the cosine of some angle a is equal to the sine of 90 degrees minus that angle a. So if you have the sine of a, you can replace it with the cosine of 90 degrees minus a. Or you could go in reverse. If you had the cosine of 90 degrees minus a, you could replace that with sine of a, and you could do the same thing with this guy. So let's come up here, and the first thing I'm going to do is replace the sine of a plus b with the cosine of 90 degrees minus this angle here. So I'm going to put inside of parentheses a plus b like this. Okay, let me put equals here, and I'll just go down this side. What I'm going to do is actually distribute this negative to each guy inside. So in other words, I'm going to have cosine of 90 degrees, then minus a, and then minus b. So now I'm going to actually group these guys together, and I'm going to say that this is the cosine of 90 degrees minus a. So let me wrap that in some parentheses, and then minus b. So we're going to treat this guy as an angle and this guy as an angle. So we're going to use that cosine difference identity. So let's come down here a little bit more, and let's say this equals the cosine of the first guy. So the first angle is 90 degrees minus a. Then I'm going to go times the cosine of the second guy. So this is just b here. Then if this is a minus, you want a plus here. So now I'm going to go with the sine of the first guy, which is 90 degrees minus a, and then times the sine of the second guy, which is b. Now, from here, I want you to remember, if you have the cosine of 90 degrees minus a, you can replace that with the sine of a. So I'm just going to say that this part right here is going to be the sine of a. That's from our cofunction identities. Then you have times the cosine of b, and then you have plus, again, right here, if you have the sine of 90 degrees minus a, you can replace that with the cosine of a. So let's say this is the cosine of a, and then times the sine of b. So that's how we get our formula that we talked about in the lesson. Pretty easy to do overall. All right, let's take a look at problem 2. So for this one, I'm going to rely on what we already did in problem 1. So now we have the sine of a minus b. So in problem 1, we used a bunch of different identities to determine that the sine of a plus b was equal to the sine of a multiplied by the cosine of b. Then we had plus our cosine of a times our sine of b. Now, what I would do here is just write this in such a way that I can use this guy, and then we can use our negative angle identities to get the full formula. So I'll go ahead and say that this is the sine of a plus negative b, like this. And so just using this formula here, we'll say this is the sine of a times the cosine of negative b, and then we have plus our cosine of a times our sine of negative b. Now using the negative angle identities, remember the cosine of negative b is the same thing as the cosine of b. So I can just say that this is the sine of a and then times the cosine of b. Now when we get to this part right here, the sine of negative b is the same thing as the negative of the sine of b. So that's going to change this sign from a plus to a minus. So now you have a minus cosine of a times sine of b. So this part matches this part, and this part matches this part. The only change is in the sign, right? This is a plus and this is a minus. So you just have to remember, if you have the sine of a minus b, this is a minus, right? So the same signs. Then if you have the sine of a plus b, you have a plus here, right? So it's always going to be the same signs. If this is a plus, this is a plus. If this is a minus, this is a minus. All right, let's take a look at problem 3. So here we have the tangent of a plus b. So how do we derive our formula? Well, the first thing is I want you to recall that tangent is sine over cosine. So just put this in terms of sine and cosine first. So we'll say this is the sine of this angle A plus B over your cosine of this angle A plus B. So that's the first step. Now, we know how to use the sum identity for sine and the sum identity for cosine. So I'm going to say that this is the sine of A times the cosine of B. And then I'm going to say that this is plus, this will be the cosine of A times the sine of B. Now this is going to be over. Down here, you would have the cosine of A times the cosine of B, and then minus your sine of A times your sine of B. So let me actually copy this, and I'm just going to paste this in here. And I'm going to put equals here, and I'm going to multiply by 1 over cosine of A times cosine of B, and then over 1 over cosine of A times cosine of B. So this is just a complicated form of 1, right? Multiplying things by 1 does not change anything. The idea is that this is going to get distributed to this, and then this will be distributed to this and this. And we're going to see a lot of stuff cancel. So let's come down here and see what that looks like. So this is going to go here and here. So let me write this as the sine of A times the cosine of B over this denominator here, which would be the cosine of A times the cosine of B. Then we have a plus here, so let me put plus. You're going to have your cosine of A times your sine of B over, again, you're going to use the cosine of A times the cosine of B. So that's this part right here. Now I got to do the same thing down here. So this times this, and then minus this times this. So let me come over here and put a fraction bar here. I'll just scooch down a little bit. And so this guy right here would be the cosine of A times the cosine of B over your cosine of A times your cosine of B. And then you have a minus here. So let me put minus. You're going to have your sine of A. So your sine of A times your sine of B over your cosine of A times your cosine of B. All right, so far, so good. It's not too bad. Let me put equals here. And we're going to see a lot of stuff cancel. So cosine of B over cosine of B, that is 1. Cosine of A over cosine of A, that is 1. This guy right here is going to cancel completely to 1 because you have cosine of A times cosine of B over cosine of A times cosine of B. So that is just a big fat 1. Let me actually put a 1 here and a 1 here so that nobody is lost. And then here, nothing's going to really cancel. Now, if I look at what's left, I have sine of A over cosine of A. Remember, that's the tangent of A. So I can say that this is the tangent of A, and then plus the sine of B over the cosine of B is just the tangent of B. And this is over. Remember, this canceled and became a 1. Okay, a lot of people make the mistake of not writing this and just putting the negative of whatever we get here. But remember, this is a 1, and you have 1 minus whatever this is. So make sure you put the 1 there, and the minus. And let me actually break this part up to make it more clear. So the sine of A over the cosine of A times the sine of B over the cosine of B. So the sine of A over the cosine of A would be the tangent of A, and then the sine of B over the cosine of B would be the tangent of B. So that's where the formula comes from. And if you want the other one, we're going to derive it in the next problem. All right, for problem 4, we're going to look at deriving the tangent of A minus B formula. So we just found that the tangent of A plus B was equal to, we had the tangent of A plus the tangent of B over 1 minus the product of these two. So we would say the tangent of A times the tangent of B. All you need to do is take and write this as A plus negative B, plug into the formula, and you're just going to see that this sign is going to change and this sign is going to change. That's all it's really going to do. So we're going to say this is equal to the tangent of A plus negative B, like this. So this is, again, just following this formula, the tangent of A plus, you have the tangent of B. In this case, you have a negative B there. So if I have the tangent of negative B, and I'll just do this now so we can go a little bit quicker. Remember, the tangent of negative B is the same as the negative of the tangent of B, right? Tangent is an odd function. So you can put a minus here and get rid of this. And so we'll slide this part down here. So you can see there's a sign change here from here. So then this is over 1 minus the tangent of A, so the tangent of A, and then times, in this case, it would be the tangent of negative B. So here's where you get another sign change. Because this is the tangent of negative B, again, you can use your negative angle identities and say this is the negative of the tangent of B. So just pull that negative out. So this would now be a plus. So our formula becomes the tangent of A minus the tangent of B over 1 plus the tangent of A times the tangent of B. All right, for the next few problems, we're asked for the instructions to find the exact value. And for problem 5, we're given the sine of 5 pi over 12. So again, if you're working with radians and it's difficult for you to break things up, just convert it over to degrees and then convert it back over. So if you have 5 pi over 12, and you multiply this by 180 degrees over pi, this is going to cancel with this. 180 divided by 12, that's going to be 15, and 15 times 5 is 75, so this is 75 degrees. So you could break this up using two angles from the unit circle, so something like 45 degrees and 30 degrees, and with 45 degrees, it's pi over 4 in terms of radians, and with 30 degrees, it's pi over 6. So you could say that this is the sine of pi over 4, so remember that is 45 degrees in terms of radians, then plus pi over 6, this is 30 degrees in terms of radians, so close that down. Let's get rid of this, and some of you don't need to do that, some of you do. It's just an extra step if you need it. So let's come down here, we'll just say this equals. Again, I'm just going to use my sum identity for sine, so I'm going to say this is the sine of pi over 4, and then multiplied by the cosine of pi over 6, then plus, we have the cosine of pi over 4, and then times the sine of pi over 6. Now, hopefully at this point, you don't need the unit circle. You have one that I've provided to you if you need that. I'm just going to go off memory here. And the sine of pi over 4, again, for the sine of 45 degrees and the cosine of 45 degrees, it's always going to be square root of 2 over 2, right? It's the same thing. So this right here is going to be the square root of 2 over 2. And this right here is going to be the square root of 2 over 2. This is the easiest one to remember. Let me put my plus here. Now the cosine of pi over 6, again, if you're thinking about 30 degrees, that's square root of 3 over 2. So this is square root of 3 over 2. And then the sine of pi over 6, that's going to be 1/2. Okay, so let's just go through and do our calculations now. So square root of 2 times square root of 3 is the square root of 6. This is over 2 times 2, which is 4. Then plus square root of 2 times 1 is the square root of 2. This is over 2 times 2, which is 4. So this gives me the square root of 6 plus the square root of 2 over the common denominator of 4. All right, for problem 6, we want to find the tangent of 255 degrees. So this would be the tangent of, let's go ahead and say 135 degrees plus 120 degrees. So this would be tangent of the first guy, so 135 degrees, then plus the tangent of the second guy, so 120 degrees. This is over 1 minus, so again, this sign right here is going to match this sign, and it's going to be different from this sign. So that's how I remember it. So you're going to multiply the tangent of the 135 degrees times the tangent of 120 degrees. So just something you have to write down a few times. So let's say this equals, and before we can continue, I need to find the tangent of 120 degrees and the tangent of 135 degrees. And again, with the tangent, it's not on the unit circle, right? So you need the sine divided by the cosine. So you can go to the unit circle and get the sine value, the cosine value, do your division, and you'll have your tangent. So for the tangent of 120 degrees, this is the sine of 120 degrees divided by the cosine of 120 degrees. Again, hopefully you know these guys off the top of your head at this point. The sine of 120 degrees, again, I'm in quadrant 2, so sine is positive, and you have a 60-degree reference angle. So this is the square root of 3 over 2. And then for the cosine of 120 degrees, you're negative in quadrant 2, 60-degree reference angle. Your cosine of 60 degrees is 1/2, so this would be negative 1/2. So here I would just say this is square root of 3 over 2 times the reciprocal of this, so negative 2 over 1. So this would cancel, and so you'd have the negative of the square root of 3. Okay, for the tangent of 135 degrees, it's really, really simple. You have a 45-degree reference angle. You know that the sine of 45 degrees and the cosine of 45 degrees, in each case, is square root of 2 over 2. But the cosine is negative in quadrant 2. So you have to think about this as, let me go the sine of 135 degrees over the cosine of 135 degrees, which is square root of 2 over 2. And then for this one down here, it's the negative of the square root of 2 over 2. So this just becomes negative 1. Okay, so the tangent of 135 degrees is going to be negative 1. We put that there. And so if I grab these two, and let me just paste this in here, I'm just going to replace the tangent of 135 degrees with a negative 1. So let's put negative 1 there. Then for the tangent of 120 degrees, let's just erase that and put negative square root of 3 there and make that a little bit better. So here, the tangent of 135 degrees, that's going to be, again, negative 1. Let me wrap this so we don't make a sign mistake. And then times the tangent of 120 degrees, that's going to be negative square root of 3. So first and foremost, you have negative 1 minus square root of 3. Can you do anything with that? At this point, no. So I'm just going to write negative 1 minus the square root of 3. Then this is over. You have negative 1 times negative square root of 3, which is going to be the square root of 3. So this is 1 minus the square root of 3. So this is where a lot of people get stuck. Let me actually grab this. All right, so I'm just coming to a new page so we can have a lot of room to work. You don't want a radical in the denominator. So what you would do in this situation, because it's two terms, you would multiply by 1 plus the square root of 3 over 1 plus the square root of 3. So remember, 1 plus the square root of 3 and 1 minus the square root of 3, those are conjugates. So we use that formula where you have, let's say, a plus b times a minus b. This is a squared minus b squared. So we're just going to use that formula. So here, let's just do the numerator first. Now, here you can't use the formula because this is not the same as the a plus b times a minus b. So you would have to FOIL this out. So negative 1 times 1 is negative 1. And then you would have negative 1 times square root of 3, which is minus the square root of 3. And then you would have the negative of the square root of 3 times 1, which is minus the square root of 3. And then you have a negative square root of 3 times square root of 3, which is minus 3. Negative 2 times square root of 3. So negative 2 times square root of 3. And of course, negative 1 minus 3 would be negative 4. So let's just write negative 4 minus 2 times square root of 3. Let's put this over. Here I'm going to use my formula. So just square the first guy. 1 squared is 1. Then minus square the last guy. Square root of 3 squared is 3. So 1 minus 3 is going to be negative 2. Let's just do that right now. And from here, we can do a little bit of simplifying. I could factor out a negative 2 from the numerator. And so I could say that this is negative 2 times the quantity 2 plus the square root of 3 over this negative 2. I'll cancel this common factor of negative 2 between numerator and denominator. And I'm left with my answer, which is 2 plus the square root of 3. All right, let's take a look at problem 7. So here we have the sine of 47 pi over 18 times the cosine of 10 pi over 9 minus the cosine of 47 pi over 18 times the sine of 10 pi over 9. So realize that this is just your difference identity for sine in reverse. So let's say this is equal to the sine of, I'm going to take the first angle, so 47 pi over 18, then minus the second angle, so 10 pi over 9. If you go through your formula, you're going to end up with this, right? So I'm just going in reverse. So if you get this type of problem, usually you're just meant to combine what's inside the parentheses and then take the sine of that. So this would be the sine of, for this I would need a common denominator. So let's say 47 pi over 18, then minus 10 pi over 9 times 2 over 2. That way I have a common denominator of 18. So this would be the sine of 47 pi minus 10 times 2 is 20. So this would be 20 pi over the common denominator of 18, right? So you have 18 here and 9 times 2 is 18. So this would be the sine of 47 minus 20 is 27. So this is 27 pi over 18. And of course, each here is divisible by 9. 27 divided by 9 is 3. 18 divided by 9 is 2. So this is the sine of 3 pi over 2, or you could say the sine of 270 degrees if that's easier to remember. And this is going to be negative 1. Okay, let's take a look at problem number 8. So here we have the tangent of pi over 18 plus the tangent of 5 pi over 18. This is over 1 minus the tangent of pi over 18 times the tangent of 5 pi over 18. Okay, coming down here, this is just me going again in reverse. So you have a plus here and a minus here. So that tells me I want tangent of this first guy, which is pi over 18, and then plus. So this sign matches this sign. You have this other angle here, which is 5 pi over 18. Okay, so I already have a common denominator. So I'll just say this is the tangent of 5 pi plus pi is going to be 6 pi. So this is 6 pi over your common denominator of 18 So between 6 and 18, you have a common factor of 6. So 18 divided by 6 would be 3. Of course, 6 divided by 6 is 1. So this would be the tangent of pi over 3. Now let's think about that for a moment. Pi over 3 is 60 degrees. So what is the tangent of 60 degrees? So the sine of pi over 3, or 60 degrees, is square root of 3 over 2. And the cosine of pi over 3, or again 60 degrees, is 1/2. So for the tangent, you want the sine divided by the cosine. So you would take square root of 3 over 2, and you would multiply by the reciprocal of 1/2. So you'd multiply it by 2 over 1, or just 2. And essentially, your 2's are going to cancel here, and you just have the square root of 3. So this is just going to be the square root of 3. Let me make that 3 a little bit better. All right, for the next few problems, we're just asked for the instructions to simplify. And for problem 9, we have the sine of negative 4v times the cosine of 5v plus the cosine of negative 4v times the sine of 5v. So again, we have a similar problem to the previous two, but it's a little bit different because we're just going to simplify here. So let me put equals. I'm just going to say this is the sine of the first guy, which is negative 4v. And then because this is a plus here, I'm going to go ahead and say this is a plus here because, again, we're working with the sine sum identity. And then I would take the 5v, the second angle that appears. Again, you can always just reverse this. If you had the sine of negative 4v plus 5v, you could set it up this way using your sine sum identity. So all you'd really have to do here is just say negative 4v plus 5v is v. So this becomes the sine of v. All right, let's take a look at problem 10. So here we have the tangent of theta minus the tangent of 4 theta over 1 plus the tangent of theta times the tangent of 4 theta. So again, using my formula, just think about the fact that this is a minus, okay? So if you're working with tangent and you have your sum or difference identity, then this guy right here needs to match what's inside there. So you'd have the tangent of the first guy, which is theta. This needs to match, so this is a minus, and then this guy right here, the second angle, so 4 theta. So this would just be the tangent of negative 3 theta. And again, using your negative angle identities, you could say this is the negative of the tangent of 3 theta. And you don't have to put parentheses there. I'll just say this is the negative of the tangent of 3 theta. All right, for the next few problems, we want to find the sine of theta plus beta, the tangent of theta plus beta, and the quadrant of theta plus beta. Now for problem 11, we are given theta and beta, not theta plus beta, but theta and beta individually. They're both going to be in quadrant 1. We're told that the cosine of theta is 3/5 and the sine of beta is 5 over 13. Let me write this down. So the cosine of theta is equal to 3/5 and the sine of beta is equal to 5 over 13. So basically, you need to get a lot of different pieces of information for this type of problem and then put it all together. Now, what I would say is that after you work enough of these problems, you start to recognize that, hey, if I have the cosine of theta is equal to 3/5, well, given the fact that I have a 3, 4, 5 right triangle, well, then the sine of theta, again, theta is in quadrant 1, would be 4/5. You could do this the slow way if you want, but for these problems, they're so time consuming. If they give you a little shortcut like that, you need to take it. So let me prove this to you real quick. So sine squared theta, we know is 1 minus cosine squared theta. So for the cosine of theta, it's 3/5, and you want to square that. So 3/5 squared would be 9 over 25. And I would write this as 25 over 25. 25 minus 9 is 16, so this is 16 over 25. And again, I would want the principal square root here because I'm in quadrant 1. So this is sine of theta is equal to 4 over 5. So again, this is the long way. If you need to do it this way, that's fine. But after you do enough of these problems, if you see the cosine of theta is 3/5 and I'm in quadrant 1, I immediately know the sine of theta is 4/5, right? 3, 4, 5 right triangle. Then this other one is going to be similar. If you think about your Pythagorean triples, you also have something called a 5, 12, 13 right triangle. So for this guy, you could say that the cosine of beta is equal to what? Well, now it would be 12 over 13, right? So 5, 12, and then you have your 13, okay? Remember, this is your y, this is your r, this is your x, this is your r. So another way you can think about that is 5 squared plus 12 squared would be equal to 13 squared. Your y value squared plus your x value squared would give you your r value squared. And you can crank that out. That would be 25 plus 144 is equal to 169, which is a true statement. Again, another way to do this would be that cosine squared beta is equal to 1 minus your sine squared beta. So 5 squared is 25. 13 squared is 169. And so this would be 169 over 169. Let me make this a little bit better. My handwriting's getting a little sloppy there. So 169 minus 25 is 144. So this would be 144 over 169. And again, we're in quadrant 1. So the cosine of beta is equal to the principal square root of 144 over 169, which is the square root of 144 is 12, and the square root of 169 is 13. So again, you get your 12 over 13. So however you want to do it, but again, you're meant to take some shortcuts on problems like these. Now, we also want to get the tangent of theta, and we want to get the tangent of beta. Okay, so for this one, it's going to be sine divided by cosine. So it's 4/5 times the reciprocal of 3/5, which is 5/3. So this is going to be the 5s are going to cancel, you get 4/3. So this is 4/3. Okay, for this one, the tangent of beta, you're going to have 5 over 13 times the reciprocal of 12 over 13, which is 13 over 12. This cancels, so you get 5 over 12. Okay, so 5 over 12. Okay, so now we pretty much have everything that we need. Let's start off with the sine of theta plus beta. So the sine of theta plus beta. Again, use your formula. So it's the sine of theta, then times the cosine of beta, then you have plus your cosine of theta times your sine of beta. Let's paste these in here so we don't have to try to remember. So the sine of theta was 4/5. Let's plug that in there. The cosine of beta was 12 over 13. Let's plug that in there. The cosine of theta is 3/5. Plug that in there. And then the sine of beta is going to be 5 over 13. Okay, so that's basically all you need. And at this point, it's just a calculation, right? So 4 times 12 is going to be 48. This is over 5 times 13 is 65. And then plus 3 times 5 is 15. And this is over 5 times 13, which is 65. And the reason I didn't cancel there is because I want to get a common denominator. If you go through and cancel stuff, a lot of times with these problems, you have to go back and get a common denominator. And it's just extra work. So now I can do 48 plus 15, and that's going to be 63. And this is over the common denominator of 65. So that's my sine of theta plus beta. So let me write that there. That's one thing that we needed. We also wanted the tangent of theta plus beta. So let me actually go to a different page here, and I'm going to work that out, and I'll come back up and answer it there. So this is what? This is the tangent of, let me actually write this down here so I have more room. So this is the tangent of theta, and then plus the tangent of beta over 1 minus the tangent of theta times the tangent of beta. Okay, let me slide this up a little bit. And I forgot my 1 there. And let's just paste this in here real quick. So the tangent of theta, I'm just going to erase this and put in a 4/3. The tangent of beta is 5/12. Let's put that in there. And then again, for the tangent of theta, you have 4/3. For the tangent of beta, you have 5/12. Now, these problems are never fun to simplify. Now, because this is a complex fraction, what you could do is think about all the denominators involved. Let me write this as 20 over 36, so I don't have to do double work here. And so the LCD would be 36, right? You have 36, 12, and 3. So you could multiply this by 36 over 36, and you would clear all those denominators. Again, this is one strategy of many that you could use. So this would come to there and there. So 36 divided by 3 is 12. 12 times 4 is 48. Then plus 36 divided by 12 is 3. 3 times 5 is 15. This is over. This would go here and then here. So 1 times 36 is 36, and then minus 36 divided by 36 is 1. So this is just 20. So this is going to give me, let me actually slide this over just a little bit, 48 plus 15. We just did that. We know that's 63. And this is over 36 minus 20. That's going to be 16. So this would be my tangent of theta plus beta. So let me copy this. So those are the first 2 answers. You're also told to find what quadrant is theta plus beta in. So you have the sine of theta plus beta, that's positive. You have the tangent of theta plus beta, that's positive. Again, just think about your all students take calculus. So let me draw this out here. All students take calculus. So everything is positive in quadrant 1. In quadrant 2, it's sine and cosecant. In quadrant 3, it's tangent and cotangent. And in quadrant 4, it's cosine and secant. So if I think about it, the overlap here, they're both positive. They're going to have to be in quadrant 1, right? Because sine is positive in quadrants 1 and 2, but in quadrant 2, tangent would be negative, right? So you have to be in quadrant 1. So let's just go ahead and get rid of this and just say that theta plus beta is in quadrant 1. All right, let's take a look at problem number 12. So we have theta and beta in quadrant 3. We're given that the cosine of theta is negative 8 over 17, and then the cosine of beta is negative 3/5. Although the problem is very tedious, we have two easy scenarios because this, you can think about an 8, 15, 17 right triangle, and this one a 3, 4, 5. So again, let me come down here and just say that the sine of theta would be what? Again, if this is 8 and this is 17, forget about the fact that it's negative, you would have 15 and 17. Think about your quadrant. You're in quadrant 3, so sine is negative, so this is negative 15 over 17. Then for this one, for the sine of beta, again, if I'm in quadrant 3, sine is negative, and again, you have 3 and 5, so you want 4 over 5, right? Again, 3, 4, 5 right triangle, 8, 15, 17 right triangle. That's where I'm getting that from. Now, again, if that's confusing for you, you can always do this the long way. It's not a big deal. So if you want the sine of theta, you can say sine squared theta is equal to, you have 1 minus your cosine squared theta. So this would be negative 8 over 17 squared. So this would be 64 over 289. So 64 over 289. And you would say that this is 289 over 289. And so 289 minus 64, that's 225. So this right here would be 225 over 289. Now, because we're in quadrant 3, you want the negative square root. So you would say the sine of theta is equal to the negative of the square root of 225 over 289, which would be negative 15 over 17. So negative 15 over 17. So again, if you don't get the shortcut or you don't realize it right away, you can just do it the long way. It's not that big of a deal. Then for the other one, again, if I have sine squared beta, this equals 1 minus cosine squared beta. So this would be me plugging in negative 3/5 and squaring it. So this would be 9 over 25. I think we've done this a million times at this point. So this is going to be 25 over 25. And so this would end up being 16 over 25. And again, I am in quadrant 3. So I want the negative square root. So the sine of beta is equal to the negative of the square root of 16 over 25, which equals negative square root of 16 is 4, square root of 25 is 5. So that's how I got the negative 4/5 for sine of beta. Okay, so now that we have that information, let's figure out our tangent. So we need the tangent of theta. That equals what? Well, we would take the sine of theta, which is negative 15 over 17, and we'd multiply by the reciprocal of the cosine of theta, which is negative 17 over 8. So this would cancel. This is 15 over 8. And then for your tangent of beta, this is equal to what? Again, take your sine of beta, so negative 4/5, and multiply by the reciprocal of the cosine of beta, which would be negative 5 over 3. And so in this case, this would cancel, and you get negative 4 over negative 3, which is going to be 4/3. So this is 4/3. Okay, so we have everything. So let's start out with the sine of theta plus beta. So again, it's the sine of theta times the cosine of beta, then plus your cosine of theta times your sine of beta. So the sine of theta is negative 15 over 17. The cosine of beta is negative 3/5. The cosine of theta is negative 8 over 17. And the sine of beta is going to be negative 4/5. So let's just crank this out. Again, because I have 17 times 5 here and 17 times 5 here, I'm not going to cancel anything. Just going to go through and do the multiplication. So negative 15 times negative 3 is 45. And then let's just write this with the common denominator now. Negative 8 times negative 4 is 32. So plus 32 over the common denominator of 17 times 5, which is 85. So this gives me, let me make that 5 a little bit better there. 45 plus 32, that's going to be 77, and this is over 85. So that's my sine of theta plus beta. Okay, so let's just bring that to a new sheet, and I'll put the tangent of theta plus beta right here. Let's go get that. Okay, so for the tangent of theta plus beta, this is the tangent of theta plus the tangent of beta over 1 minus the tangent of theta times the tangent of beta. So let's see what we're going to have. So the tangent of theta is 15 over 8. Then plus the tangent of beta is 4/3. This is over 1 minus the tangent of theta, again, is 15 over 8. And then times the tangent of beta, which is 4/3. Okay, so lots of different ways to simplify here. Again, the strategy I'm going to use, you could multiply this together now. I would not cancel anything because you have an 8 and a 3 and then an 8 and a 3. And if you go through and cancel, you're going to end up with the same answer. So what I'm going to do is say this is going to be 15 times 4, which is going to be 60 over 8 times 3, which is 24. So we don't have to reduce that right now, because what I'm going to do is say this is 24 over 24 that I'm going to multiply by, because you have 8, 3, and 24 for the denominators, so the LCD is 24. So this would get distributed, and we would say 24 divided by 8 is 3. 3 times 15 is 45. Then plus 24 divided by 3 is 8. 8 times 4 is 32. And this is over 24 times 1 is 24. And then minus 24 divided by 24 is 1. So you basically just have 60. So 45 plus 32, that's going to be 77. And this is over 24 minus 60, which is negative 36. So this is negative 77 over 36. So let's write negative 77 over 36. For the quadrant of theta plus beta, sine is positive, tangent is negative. So let's think about this. Again, if I use my poorly drawn coordinate plane here, all students take calculus. In the first quadrant, they're both positive. So that's out because this is negative. In the second quadrant, sine is positive and tangent is negative. So that's where I am, because if I go to quadrants 3 or 4, sine is going to be negative, right? So it's got to be in quadrant 2 where sine is positive and tangent is negative. So I'm just going to say that theta plus beta is in quadrant 2. All right, for the next two problems, the instructions tell us to verify each identity. And let's start with problem number 13. So we have the tangent of theta plus 1 over 1 minus the tangent of theta is equal to the tangent of theta minus 135 degrees. So what I'm going to do is work on the right side here. This side will be unchanged. So this is what we're going to try to get a match with. Let me put my equals all the way over here. And I'm going to use my difference identity for tangent. So let me scroll down just a little bit. And I'll start off by saying this is the tangent of theta. Again, this sign always matches. So this is a minus the tangent of 135 degrees. And then over, you're going to have your 1. And again, this sign is always different from this sign. So this is a plus. And you're going to multiply this by this. So the tangent of theta then times the tangent of 135 degrees. Now, we saw earlier that the tangent of 135 degrees is negative 1. So you would just plug this in here and here. So we'll say that this equals, let me come down here a little bit, the tangent of theta. And then basically you have minus a negative 1, which is plus 1. Let me scroll up just a little bit. And you can see that matches what we have there. Then this is over. You're going to have 1. And then basically, instead of the plus, this becomes tangent of theta times negative 1, which is just the negative of the tangent of theta. So you just put minus tangent of theta, and so we have a match, right? So tangent of theta plus 1 over 1 minus the tangent of theta. And here the tangent of theta plus 1 over 1 minus the tangent of theta. So I'll just put a check mark. All right, for problem 14, we're going to verify this identity. So we have the cosine of, you're going to have this theta minus beta over the cosine of theta times the sine of beta. This is equal to the tangent of theta plus the cotangent of beta. So let me actually flip this. This is going to be the simpler side, and this is how I like to format it. So let me put the tangent of theta plus the cotangent of beta. And this is equal to, again, I'm just going to copy this. So the cosine of theta minus beta, and then over the cosine of theta times the sine of beta. Okay, let me come down here a little bit, and I'll put the equals all the way over here. I'm going to use my cosine difference identity here for the numerator. So this is the cosine of theta, then times the cosine of beta. Then this is a minus, so I want a plus. And this is the sine of theta times the sine of beta. Okay, now what you could do is actually split this up and put this part over this denominator. So this would be the cosine of theta times the sine of beta, and then put this part over the denominator. So the cosine of theta times the sine of beta. Again, if you are confused about this, if you were presented with this, you have a common denominator. So you could write it as the cosine of theta times the cosine of beta plus the sine of theta times the sine of beta over the common denominator of the cosine of theta times the sine of beta. So from here, what I would do is actually cancel this and cancel this. So what you have now is the cosine of beta over the sine of beta. That's going to be the cotangent of beta. And then plus the sine of theta over the cosine of theta is the tangent of theta. So we're almost there. Remember, the order was flipped, so we want to match that. We're just going to change the order of the addition here and say this is the tangent of theta plus the cotangent of beta, and we're done.